Okay, good afternoon, everyone. My name is Sam Nasr, and this is 14 T-SQL functions you may not know. Before we get started, just a couple of overhead items. A little bit about me. Been a software developer since 1995. I work in an organization called NIS Technologies that I started. We do consulting, education, as well as custom applications. Hopefully some of you had stopped by previously during the day, gotten some candy, gotten to see the Stormtrooper, and gotten one of our brochures. I've achieved a few certifications from Microsoft. I head up the Cleveland C# VB.NET user group, and I've also headed up the .NET study group online. I've been an author for Visual Studio Magazine for several articles. A lot of the content that we're going to discuss today is already online, and I'll share that link with you afterwards. And I've been Microsoft MVP since 2013. Some general info, restrooms if needed are out this door, straight down the hall, and on the right-hand side. Please keep in mind that participation is encouraged despite the classroom-style seating. Feel free to jump in with questions or comments at any point in time. And last but not least, if you would please, mute your cell phones. I always like to ask, how many developers do we have in the room, by show of hands? All right. So I'm going to rely on you folks for several questions as we proceed. So I need you to participate with me. I also wanted to point out, this is one of the user groups that I run and been doing it for 15 years. Very active. We do basically discuss anything and everything related to .NET. How many of you are active in the user group community in your area? Okay, so very few people. So for those of you that are not, let's find out why. Time. That ever so expensive commodity, right? Why else? There is none. Okay, for those of you that do attend, what advantages do you get out of attending the user group? You learn technical things, right? What else do you learn? Networking. One of my favorite quotes by one of the Microsoft tech evangelists, he said, the most important person in the room is not the one standing in the front, but rather the one you're sitting next to. So it's important to get out there and network and mingle with colleagues. And it's not the guy waving his hand in the back either. In any case, I strongly encourage you to sign up. We're on meetup.com. And again, it's the Cleveland C# VB.NET user group. Launching into our presentation, 14 new T-SQL functions. They're not really that new. They've been around for a while. It just surprises me that not many people know about them or have worked with them. So this is the 14 functions. These are the 14 functions broken down into 4 different categories. We're going to look at conversion functions, followed by data type functions, and then we're going to move on to 2 logical functions, and finish off with 2 string functions. So with that, getting started with the conversion functions. What we're going to be doing is we're going to look at parse, try convert, and then try parse. So with parse, what this does is essentially it takes a string value, and then we specify in our T-SQL what we want to parse this value and what we want to get out of it, meaning that we are converting the data type. We also have this optional using culture, and you notice that it's in brackets because it's optional. And this will require the .NET CLR, so it cannot be remoted in from another machine, but rather it needs to run on the server itself. So with a parse function, it's used for converting strings to date, time, and numbers. If you want to do general conversion from one type to another, you would essentially use either the cast or the convert. And then we can transform patterns, or the patterns that are specified are limited by the styles in the .NET CLR. The reason for this is basically built on the common language runtime in .NET, and so it utilizes the style, which we'll talk about in another slide. It uses the slides that are formed in the .NET framework. The other one that's used for conversion is the try_convert. So for the .NET developers in the room, what is the difference between parse and tryparse? In .NET, that is. Exceptions. Can you elaborate a little more? Okay, so with a parse, it will throw an exception if the conversion is not successful, right? But if we indicate the try_parse, that will return a null if the conversion is not successful. So because it is built on the .NET Common Language Runtime, that same methodology carries over. We have the try convert, where we specify the data type, we also specify the length, and then an expression of what we want to convert it to. And so we'll convert the expression to the specified type, and it returns null if it's not successful. Again, because we're starting with the try underscore keyword. Let me rephrase it. It is, the way it's called is try underscore convert. And so following the .NET methodology, if it's able to convert it successfully, it will. If not, it will return a null as opposed to throwing an exception. And so the style that we see here, the parameter at the end, what this is, it's an integer expression that is used to specify the format of the end result. And essentially, to find out what style is going to be useful, you essentially have to look it up in the Microsoft documentation to see what style would be adequate. And we'll run through a few demos of those in just a little bit. One caveat, if we specify null for the style, then null is returned as the final answer. And then the third one for the conversion is the try underscore parse. And every time we see the try, that means that essentially it will return a null if it's not successful. So same thing with this function as well. It will take a string value and it will convert it to the data type that we specified. And here we have the optional culture parameter that we pass in. So it's similar to parse, except that with the try parse, it will return null as opposed to throwing an exception. So if we go through a demo of that, by the way, the slide presentation as well as the demo has already been uploaded to the SQL Saturday site. And for the demo, I'm essentially running functions and I'm not querying any data. So this script will run as is on any machine. You don't necessarily need to install a database. The caveat here, though, is that it requires 2012 or later. And so what I have is the parse function. And what I'm doing here, you'll notice that I'm parsing a string and I'm converting it to a float. And when I execute this, no problem, it returns it as a numeric value. Now I'm going to utilize the culture parameter that's optional. And so here I'm converting 331 into English US. And so it will convert this string into a date time. And when I execute it, because I didn't highlight the whole statement, it gave me an error. So we'll try it again. And there it is, a valid date time 2 data type. Okay. Now let's throw some monkey wrench into the works. We're going to convert the same string, except this time we're going to use English AU, which is what? Australian. And so when we convert it, we get an error message. Oh, sorry, I highlighted too many lines there. When we convert it, we get an error simply because in Australia, it starts with a day, month, and then the year. And so we're using that culture as the parameter. There is no month 31, and therefore we get an exception. Okay? Likewise, we can use the parse function, again, using the Australian culture. And we tried converting that, that doesn't work. And again, simply because we're using the semicolon as the delimiter there. So it's not valid to convert that into a datetime2 function. When we run the following statements, and that's using a short date format, that will convert into a US function as expected. And there it returns a valid datetime2, and there we see the 7 decimal place precision. Okay? Any questions so far? Is it pretty straightforward, or is it just we're approaching 5 o'clock and things are getting rough? Which is it? All right, hang in there with me. Okay, so next we're going to look at the tryparse function. By the way, folks in the back, can you see that okay? Okay. So we have the tryparse function, and likewise, similar to its counterpart with parse, we have the culture as a third parameter, and here we're able to convert it without issue. When we use the same thing, now notice that I'm using the US English format, and I'm specifying month 13, which is invalid. But because I'm using the try_parse, it doesn't throw an exception, but rather it returns a null. And then likewise, if I try to convert a string where it cannot be cast into a datetime type, as I'm specifying here, the conversion is not possible, and so it returns a null as well. So you might be guessing, what is really the difference between parse and tryparse, other than the null versus the error, right? That's essentially it. It's the null versus the error. And so here we have the two functions side by side. And when I try to execute these three statements, we'll see that the first one is successful. However, the other two throw an error. And again, that's because I'm using the US format and I'm passing in a month 13. Same thing with the tryparse. Pardon me. Same thing with the tryparse, except this time it returns null instead of throwing an exception. Okay. The last conversion function that we talked about was the try_convert. And then what this does is we specify the date type, and then when we want to convert a specific expression too. So here we're passing in a string, and we want to convert it into a datetime2 function, and we execute that without issue. Now notice with a try_convert, I can do string types as well. So here I'm converting a string into a substring. And if you recall from the previous slide, where we have length as an option whenever we're converting types. So here I'm taking a 5-character string and I'm converting it into a 3-character string. And so this conversion is obviously legit, and we get just the first 3 characters back. With this statement, when I try to convert 4 into XML, why is it that I get an error? I'm sorry, I heard that faintly. It's not a string, correct. However, the following statement, where I do make the 4 into a string value, it returns it as valid XML. And if you don't believe me, let me click the 4, and there it opens up an XML document with the value in it. Okay. This time I'm going to do the opposite of the previous statement that we did. I'm going to go from a shorter string to a longer string. And when I run the try_convert on it, I'm going from an 8 string to a 9 string. You'll notice that it appended a space at the end of it. Okay, so we're going from a string to a string, and we can play around with the size there as well. If you remember with the try_convert, we said that we have this style expression that we have available to us as an optional parameter. Where do I find the style? How do I know what style to use? What is it going to look like? Where's that documented? MSDN or Microsoft Docs, right? So this is something that was originally in the .NET framework, and then it carried over into SQL Server. And so looking at it in more specific, I'm going to run a few examples here to show you what the style is going to do. I have the try_convert, and it's working on converting the current date into a varchar 50. And here I'm specifying the third parameter, style. And you see that it's incremented 1 through 14, and then I jump to 101. And so when I run them, what you see is we have the date format, but it appears in different, or I'm sorry, we have the same date, but it appears in different formats, simply by specifying the style. And style is really nothing more than an integer value that indicates how that data is going to be formatted. Okay? All the different styles? Yeah. Right. So this is one quick way to find out instead of looking up the bookmark, right? You can just run it for several styles and you can see what's going to be presented there. Any questions? The first three, they do. I don't think the others do. But we'll go through it, each function, one slide at a time. So moving right along, the next section is going to be date and time functions. Some of these are rather repetitive, and you'll see what I mean in just a second. But what we're going to be doing is we're going to be building a date time value from individual parts, meaning we're going to pass in individual parameters to create the date time value. So the first one is called date from parts. And what we're doing here is we're building a date, year, month, day. So we pass in three individual parameters that are integer values, and then it returns a single date time type, or date type in this case. So again, it cannot be executed remotely on an earlier version of SQL Server. It does require 2012 or later, and all values must be valid date values. For date time from parts, again, because now we're building a date time as opposed to just date, now we have the year, month, day, in addition to the hour, minutes, seconds, and milliseconds. So now we're returning a full date time value type. A couple things to note: if the arguments are not valid, then we have an error that's going to be raised. If the required arguments are null, then we have a null that's returned as the result. And then building out date time from parts, you can see now this is where it's starting to get a little bit repetitive, but at the same time, it's very intuitive, right? So I don't want to take a stab at what date time 2 from parts is going to do. It's going to return a date time 2, right? So prior to 2008, Microsoft had a value in SQL Server called date time. Then 2008 came about and they wanted something with higher precision. And so a lot of the developers were scratching their heads. What do we call it? Oh yeah, date time 2, right? So here we have date time 2, and this has a higher precision value. So we pass in the standard year, month, day, hour, minutes, and seconds, and then in addition, we have fractions and then the precision value. That's a possibility, very true. Pardon me. So all values must be valid date time values, and we have a precision that must accommodate the fraction value. And we'll see what that means as we step through the demo. And the one thing to note, that last bullet, the maximum precision is 7. So we cannot exceed that. In addition to date time and date time 2, now we have, in 2008, they introduced date time offset. And what this does is now we can put in an offset that will represent different time zones, so we can compensate for it as we go to different time zones with a specific date. So date time from parts, again, similar to its other counterparts, we'll take all the individual values, and now you see that we have an hour offset that's included in here, as well as a minute offset. We have all the other standard values, year, month, day, hour, minute, seconds, fractions, and precision, and then right in between we have hour offset and minute offset. Yes. So let's step through a couple examples of those. So here we have the date from parts, and that's just going to build a short date value, no time specified. Here you notice that it's essentially the same statement, date from parts, except I have a leading 0 on month. But when I execute that, that runs without issue. Pardon me. And then what happens when I have an invalid value? I get an error that's thrown. And then we have date time from parts, where now I have individual integer values representing each segment of the date time. And because I specified all valid values here, it returns a initialized date time value. And so here we have date time 2 from parts, where now we're getting into more detail, where we're specifying a precision value, how many decimal places we're going, and the fractions of that second. So taking a look at this example, it's much easier to actually demo this than to actually explain fractions and precisions. So once I execute this, we now have a valid date time 2 value. Here is the date, August 18th, 2012. The time, 14:23 and 44 seconds. The fractions of the second is 5, and then the precision is 1. So I'm going one place beyond the decimal point. And so even though it's a date time 2 value, you'll see that it's 44.5, and then I don't have any trailing zeros. Okay? So this is where you have to be a little bit careful as you're putting in these values. And you'll see that in the following demo. So here I have the value of 50, and I specify a precision of 2. And now it presents the same date time value type. Now it's .50 for the seconds. Now here what I'm going to do is I'm going to specify 7 decimal places and the same fraction. And you'll see that now I have a completely different value because of my precision. Once again, my cursor is blocking it. There we go. So I'm specifying 5 for the fraction of a second, except I want it in the 7th precision value. And so there you see the 5 is put all the way to the far right, or the 7th decimal place. Okay. Now, so far I've been entering in valid values. Everything is straightforward. Now, again, let's throw a monkey wrench into the works. So here we have a date time value. I'm specifying the fractions as 50, but a precision of 1. So what will happen here? It's invalid. What does the error message say? Some of the arguments are not valid, right? I can't put a 2-digit number into a 1-digit slot, essentially. That's what's happening here. I'm specifying a fractions of 50, and I'm specifying a precision of 1. If I have a precision of 2, will it work then? Let's give it a shot. Let's take some bets first. How many think? No, kidding. All right, so we execute it, and there it is as a valid value. Likewise, if I specify a precision of 8, what's going to happen here? Why an error? Precision is 7, right? And here I specified 8, and therefore it errored out on me. Precision of 7, yes, but here I specified precision of 8. Maximum precision is 7, right?
So if you say precision 6 or 7 or whatever, it always displays that number of decimal places.
It will have to accommodate that number in those decimal places. It won't truncate it, as we see here when we did the, where did we do it? Right, so I can't specify 50, so let's go up here, for example. Here's a 50, and I'm going to squeeze it into 1 precision, and when I run it, I get an error. When the precision's larger, right, so when the precision's larger than the digit that I'm putting in, then I specify where that number is going to go as far as the precision. So in this case, I think this is the example you're referring to here. You'll see that 5 is in the 7th place.
It just shows difference. It'll show as 5 zeros.
No, there won't be any trailing zeros here. I mean,
But if you run that one and the next one at the same time, see the compared to the result? Yeah.
Right, but I'm putting a 5 versus a 50. Okay. The bottom line is my precision has to accommodate the fraction value that I'm putting in. Okay. Again, I'm just pointing out caveats, so as you're working with this, it doesn't trip you up. Actually, we can minimize the object browser, and now we have more real estate. So now we can talk about the date time offset from parts. And so as you recall, it's the same thing as its previous counterparts, except now we have an hour offset and a minute offset. And if you notice, again, this T-SQL script is already uploaded to the SQL Saturday site. The reason I did this with the spacing is you can see what the value is for each parameter that's being passed in. And so here I'm going to do the date time offset. And the first one is the happy path, runs with no problem. I specify 1230 for the hour and minute offset, and then where's my fraction, 5, and then a precision of 1. So it accommodates it, everything works well. Okay. And then same thing here, 50 with a 2 precision value, that will also produce a valid value as well. And the same thing with the third, here I'm specifying 500, and the precision value can accommodate it here. Okay? Yes, sir?
What is a fraction?
What is a fraction?
In this case, what is a fraction?
Okay. Who wants to take a stab at the answer? What does the fraction refer to in this case? And don't say part of a number. Don't pull out a pi. It's the fraction of a second.
So if we look at it in more detail, we have the date that ends here, 11/8/18, 14:30, there's the minutes, and then 00 per second, and here there's a decimal place, 0.500. So the fraction of a second is essentially 500th of a second. Okay? And then here I'm specifying the offset after. The key thing to remember, the fraction value that I specify I also must specify a precision value that will accommodate that. Make sense? You guys are trusting me. It's 4:30 and we're doing math and precision, fractions. This is kind of.
But it's still half a second, though, no matter how you look at it, right?
I'm sorry?
In those examples.
Correct. Right. So 0.5 is the same as 0.500. But since we're building a date time value from individual parts, you got to be careful what you put in. That's what I'm getting at. Okay? Any other questions? All right, since we're doing very well, let's ramp it up a notch. Let's go to EO month or end of month. So, any accountants in the room? No? All right, find an accountant friend and you'll make them happy by telling them this. But this function, what it allows you to do is to be able to return
The end of date or the end of month date for the month specified. In addition, you can add the number of months to add to the start date that you specified here. Okay, I know some of you are kind of giving me a wide-eyed look, but we'll walk through the example.
And the reason accountants like this is because they want to know what is that last day of the month and what is the last day of the month after I fast forward a few months later from now. So we have an optional value of months to add to it.
And the way it works is that the value that we specify here is added to the start dates, and then we look at that date that we end up in, and then we see what is the last date of that month that we ended up in.
Yes, ma'am.
Under the hood, is that really just doing a add? You know what I mean? You know,
Can neither deny nor confirm that statement. Under the hood, I don't know for sure.
The key thing to point out is this last bullet. If this addition overflows the valid range of dates, then we have an error that's raised.
And so if we run through an example of that, here we have EO month. So we're going to look at August 18th, 2012. And when we execute that, we know that there are 31 days in August. And so it produces the last date of that month, of the date that's specified. So this is, we passed it in an August date, August 18th. We're looking for the date of the last day of that month that we're in. Okay? Make sense? Good. Let's ramp it up another notch. So now what we're going to do is we're going to take that current date, add 6 months to it, and so when we run it, what it's doing is it's looking at August 18th, it's adding 6 months to it, which puts us in February of 2013, and then we look at the last day of that month, which is the 28th. Make sense? So I'm, yes, sir.
What happens if you add 6 months to August 31st?
Okay, so if we look at, let's change it here, August 31st, and we add it in, it will be the same month because it's not counting the number of days, but rather the months that it's adding on. Okay? Like that? So it accommodates for leap year. Fellow mathematician? Right. So in the past, you had to do some calculations to find out if it's leap year, find out if it's February, and be able to get the last date. Here, it's just a simple call, EO month. You pass in the number of months rather, you want to advance from that start date, and then it gives you the last day of that month. Yes, sir. Can we add days instead of months? No, we cannot. Okay, onwards and upwards.
Outside of accounting, I mean, these are all static numbers outside of every 4 years, right? So is that valuable for anything non-accounting?
It would really depend on a scenario by scenario basis where this would be valuable. And so prior to this function, did you have to do basically a large procedure that you ran through to do the calculations and accounting for leap year and whatnot? Now you don't, correct. But I was referring to Dan's question. Obviously, you're not using EO month, right? Mm-hmm. Okay, so which is easier? Right. Oh, absolutely.
But what I described, even experienced developers will look at that and they'll have to write it out.
Oh, yeah.
They'll say, what happens if I truncate the date? You know, it's very confusing, whereas this tells you what it is.
Absolutely. It's better to have something tried and true that works out of the box instead of something that someone did and God knows where they're at. Right? Yes, ma'am. Oh.
I was just going to say, you can truncate a date like on 10 different things, and it depends on different values. You can truncate on the day, date, month, year, week, trimester, and you get a different date. So it just depends on the format.
Right.
Usually people have to look them up to see it.
Yeah. Yes, ma'am. You're stealing my thunder, ma'am. Yes, we're moving forward. That's exactly what I have. Yeah. I'm just slowly ramping up the crowd with me. Keep in mind it's 4:30, so. But yes, that's a very good question. So here, as suggested, what happens when we put in a negative value? So negative 15.1, we're not just putting in a negative value, we're putting in a negative value and a decimal. Okay. So now we have negative 15.1 going back from August 18th, 2012. And so when we run this, who's the mathematician in the room? So is this 15 months or 15 months in a day? So right, so it's 15 months, and it is able to go backwards in time as we see here with a negative value that we gave it. Okay, and if you notice that when I run these two, it produces the same date. May 31st, 2011, regardless whether it's a decimal or not, that doesn't affect it.
15.9.
All right, once again, you're stealing my thunder now. Okay, so now we have, what if we add in 0.49 versus 1.99? So when we run these two, essentially 0.49 would equate to 0, and so it returns the last date of August 2012. When we add in 1.99, which we would expect to round up to 2, it truncates the decimal portion because we're looking only for an integer value. And so we truncate the decimal, we regard this as simply the value of 1, and so we're adding one month to August, and so that produces September 30th. It's only looking for an integer value, okay, as opposed to a decimal. So we don't round, we just simply take the integer value. I'm sorry? I can't hear you.
The floor.
The floor?
The function.
Right, yeah. Now we're going to take month 13 and add in 6 months to it. And of course, that's going to cause an error because it's an invalid date to start with. So you see that culture is important. I'm specifying August 30th in an Australian format where I have the date, the year, the day, and the month, and I'm adding 1 month, and then when I run this, obviously it's invalid because it is looking at it from a US culture perspective. Okay? Any questions about EO month? With EO month? I don't believe so. No, it's not one of the optional parameters there. And then going along the lines of the building a datetime value, we also have small datetime from parts. And again, this just builds a small datetime value just from the individual integer values that we pass in. Likewise, we can just retrieve the time alone from individual values. And again, these all have to be integer values, and it's going to return a fully initialized time value when run successfully. As we had seen in the previous slides, if the arguments are invalid, then we have an error that's raised, and if any of the parameters are null, then we have a null that's returned. So anytime you pass in an invalid value, unless that function starts with try, it's always going to return an error if it's an invalid value. And just looking at the script briefly, small datetime from parts, again, nothing earth-shattering here. We run it, we specify all the integer values, and it returns a datetime value. Here, we're going to specify null for the day, and when executed, because one of the arguments is null, naturally the entire value returned is null. And if we pass in an invalid value, then we get an error that's returned. Same thing with time from parts. What I wanted to demonstrate though is with the time from parts, now we're playing around with some fraction values. So here you see the alignment of the values and the parameters. For seconds, I'm using 34.612, but the fraction of 500 and a precision of 3. So what is it going to put into that precision value? When I execute it, basically we're looking at integer values for each parameter. So we truncate the .612, and then we look at the integer value for the next parameter and the next parameter. So this one, the fraction is 500, precision is 3, which accommodates it, and so the final value has a .500 for the seconds, or for the fractions of a second. Okay? Again, the key thing to remember here, we only look at integer values, truncates everything else. I'm going to jump ahead. Time from parts, essentially same thing. Here we're specifying the precision, and if we execute with a -3 for the precision value, obviously that throws an error because precision needs to be has to be a maximum of 7, cannot be negative, okay? And same thing, if we ever have a null value, it's going to return, oh, let's do that again. Whenever we have a null value, it will return a null, except if we specify a null for the precision, that's going to throw an error. All right. So this is where things start to get a little more interesting, beyond how interesting it was previously. So now we're going to talk about logical functions. And for the .NET developers in the room, what choose does is basically you pass in an index value, and then you pass in a list of values. So typically for C# developers, what do we say every integer or an array starts with what? 0. It's 0 based. The T-SQL world is a little bit different. We now have a 1 based index. So this is a gotcha right here. So you specify the index, this is value 1, this is value 2, there is no value 0. So you got to be careful with that. It will accommodate, I believe, up to 255 values. Another catch is this bullet right here, where it turns the data type with the highest precedence from the set of types passed to the function. So the way it works is you can pass in a variety of different values, meaning integers, strings, binaries, XML, what have you, and it will evaluate it and it will return the data type that matches with the highest precedence among that entire list. So what am I saying by precedence? If we take a look at the Microsoft Docs briefly. Oh, I lost that site. Okay, I accidentally closed it. But let's go to my cheat sheet. And here we have 30 different types that are specified from lowest to highest for the user-defined data types in T-SQL. Can I zoom in a little? Sure. Let's do this. So again, SQL_variant and XML are the two highest, and then binary is the lowest of the precedence value. So I can pass in different data types, but the value that's returned must match the highest precedence. This is where it gets a little bit confusing, just a little bit. And if it's not able to do that conversion, then it throws a null. So two things to remember here. Number one, it's a one based index, and it returns the type of the highest precedence. If we look at the following function, which is the inline if, what this does is, it's similar to the ternary statement in C#. What we do is we specify an expression. If it evaluates to true, we execute the following portion, and then we have a colon that separates what happens if we don't meet that expression, right? So it's the same thing here in T-SQL, where now we're specifying an expression that's going to evaluate to true or false. Here we're going to specify the value to return if it's true, and here we specify the value to return when it's false. Also, I can have two different value types here, but the return type must match the highest precedence from the list of types that are specified, meaning either the true type or the false type. And essentially, behind the scenes, the inline if is translated into a case statement. And so with inline ifs, as well as with case statements, we can nest them up to 10 levels deep. However, this definitely falls in the category. Just because you can doesn't mean you should. And you'll see an example where I nested it 2 levels deep and I was ready to hang myself. So let's step through an example of that. So here we have a logical function, and this is a straightforward example and a viable case of where this would be used. So I'm going to pass in an expression here. Let's say that I have, in my job title, I'm specifying a numeric value to specify where each employee is as far as ranking, whether they are director, manager, or employee. So it's an integer value, and I want to translate that into a text value. So here I'm passing in the expression, which is just a simple number 3. And what it's going to do, it's going to count how many values. What should this return? Developer. Again, it's 1 based index, and when I run it, I get developer back. All the data types are the same, so there's nothing odd that's happening here. But what if we were to change it up, and now we have a combination of things? We have a date value, we have a numeric value, and then we have string values. So what's the highest precedence among these? I believe it's dates. So once we execute it, first of all, before we execute it,
let's walk through how it's going to work. Here we have the integer value for the index. So which value is going to choose?
Director, and director is a string in this case. So when we execute it, it's going to choose director, and then it's going to try to convert that to the highest precedence type among that entire list. So when we execute it, it cannot convert director to a numeric value. So numeric was actually the highest precedence here, and it was not able to convert it, therefore we got an error.
Is that a date or just a number? It's like a number of digits, that's close. So that's 08 divided by 18 divided by 2012. Or fancy way of saying 0.
Correct. Yeah, it is, you're right, it is a numeric value. Correct. So you see where the confusion can happen here. Obviously, you can have different data types in here and it will do the conversion for you. But again, just because you can, doesn't mean you should. So this is very bad practice.
You shouldn't even do this, but if you do decide to do it, that's what's happening behind the scenes. It will do the conversion for you,
and you are facing the potential of an error. Let's take the next example. Here we have index of 1, and here we have several string values, we have a date value, and we have a numeric value. So when we try to run this, again, walking through it one step at a time, we're looking at the first value, which is a string, and it's going to try to convert it, I believe, to a date time value in this scenario. And when we execute that, again, numeric is the highest precedence, and so we still end up with an error here. So this is a date, because so
if you get rid of, so what happens if you get rid of the 42.325 there? Because it should either convert it to date, which is the higher time, or to the string. I tend to won't convert. I tend never work.
Okay.
So it didn't convert it to date.
So it's a string.
So,
right.
But if you now convert that to date, then it will fail.
If I now convert that to date.
If you convert the fourth parameter to date.
Mm-hmm.
Now cast that to date.
Right. Then it would fail.
Then it would fail.
Right. Because now it's trying to convert a string, which is not going to be a valid date on conversion. Director cannot be converted into a date. Correct. Yes, sir. Right. So you could actually have.
So you could have a specific column value that's specified in the first parameter to indicate which value you're going to be using.
Meaning, if I had the let's call it employee rank column. Then I could use that, when I select from it, it's going to return a 3, and then from there I can decipher whether that employee is a manager, director, or employee. Make sense? And I kept them with static values here, again, because to make the sample script more portable. Now here, I have all string values, but I'm choosing an index of 33, which is beyond the list that I have. And so executing this will return a null. Doesn't return an error because 33 is a valid value, it goes up to 255, but I didn't specify what that value is, and so therefore it returns a null. Okay. Likewise, as I was mentioning, you can specify select statements inside your choose, as I'm showing here, but it would be column values that would be returned here. And so you can embed those as well. Next is the inline if, and what this does is, basically we're going to convert the expression, evaluate the expression, and it's going to return a string true underscore value if it's true, or a string false underscore value if it's false. And then here, I have two hard-coded integers, A is 45 and B is 40. And so naturally, when I execute this portion, it returns a true value. Remember what I said a minute ago about nesting? If you were to get a support call and you need to decipher this, it would be a little complicated, right? And this is only 2 levels deep. Imagine maximizing it and going 10 levels deep. It would make it pretty hairy. So the last thing you want to do is nest these things. And so running through this, it returns a false. And if you walk through it, you can understand the confusion, or someone else can easily get confused. So here it's an inline if, I'm evaluating as A greater than B. A is greater than B, as specified in my declare statements. So it's going to go to this, which is the true value. The true value is the nested inline if. So it's going to land here. Now I need to evaluate this in order to return a value. So I evaluate this expression, and this is saying it's A greater than B, which is true. However, in here, I have the string false. Okay. An example of how not to do things.
Let's go from left to right.
I'm sorry? It's not like an algebra expression where you evaluate things inside out. No.
Yeah.
Basically, it evaluates the expression, then it either jumps to evaluating this true statement or the false portion. And so here, in my true statement, I deliberately twisted it around to show you how difficult something like this would be to debug. Okay, lastly, because I'm running tight on time, I just want to cover the last 2 functions. So concat, let's go to the slide deck. So with concat, I can essentially specify a variety of string values. Here you see string value 1 to string value n, where it will require a minimum of 2 values up to a maximum of 254. And then what it will do is essentially concatenate them all together, and it will return a string of the concatenation of those values. So the arguments are implicitly converted to string types. Null values are implicitly converted into an empty string, so I can pass in nulls. And if all the arguments are null, then an empty string of type varchar1 is returned. That's the caveat you need to keep in mind. The last one we're going to talk about is the format statement. So again, this should be very familiar to the .NET developers. And with a format, what we're doing is we're taking a value and we're specifying a format of how we want that value to be represented. And then we have an optional culture parameter that we can pass in.
So it returns a value formatted with the specified format. And then the format that we specify here must contain a valid .NET Framework format string.
So again, this is building on what's in the common language runtime, and it's utilizing it. So if we take a look at an example of that, so here's my concat. I'm passing in a variety of different values. I have 2 strings, an integer value, and then 2 additional strings. And it's very easy to convert a string, or excuse me, very easy to convert an integer into a string. And so it converts that 11 into a string, appends everything together, and there's my happy path. Everything comes back as a string. If I pass in nulls, and if you notice, I have no spaces between happy and birthday, but when I run it, I get happy birthday butted up against each other. If I pass in all nulls, what is that going to do? Not quite. It will return a varchar1 string. Tricky, tricky, right? And then if I pass in just a single value, that will cause an error because I'm required a minimum of 2, a maximum of 254. With the format statements, does this look familiar to the .NET devs? Kinda, sorta, okay? So here we have the date time as a variable that we're specifying to August 18th, 2012. And here's a link to where we can find the format strings in Microsoft Docs. And we have an optional cultural parameter. So I'm going to take August 18th, and I'm just going to pass in the format of D, and we'll see what that looks like in both English and US. So I want a date format. So D specifies it's a return a date format for the selections. And the English US format is 8/18/2012. In the second statement, I specify Australian, and now I have 18/8/2012. Again, I'm passing in the same value for both, but it's just the formatting for the culture is what causes it to differ. Okay? Any questions? None at all? All right. So continuing on, if there's no questions, then I have some questions for you. What did we talk about today? Date time, conversion parsing, what else? Sorry? Inline if? What can you tell me about inline if? How to use it and how not to use it. Correct. What else did we cover today? End of month function to impress your accountant friends, right? What's so interesting about the EO month function?
Yeah, make sure you're adding valid dates.
Make sure I'm adding valid dates. What's an example of an invalid date?
I would guess if you try to have 1 month, January 31st, it would work out so well since it's on February.
No, it would work out. Right. Right. My January 32nd won't work. So the start date has to be valid, and then it takes the integer value of the month to add. So as a recap, we talked about 14 different functions. There's a link for these over on Visual Studio Magazine. So if you click this link, it's not misleading you. It will be titled 4 T-SQL statements, but then there's a link for 10 additional. When I wrote the article, it was just simply too long to put into one, and so the editor broke it out into 2 articles. There's also a link for the string formats and the format styles. Lastly, this is part of a course that we're building at NIS Technologies. If you're interested, feel free to reach out. You can browse our website, again, NIS Technologies, and then click on the education portion. There's a list of the SQL Server classes. These are classes that are tailored to the end user as opposed to canned courses at specified pre-scheduled times. Everything is essentially revolves around the end user. Lastly, my contact information.
SNASR@NISTechnologies.com. You can also find me on Twitter, and I wish you to connect with me on LinkedIn.
And with that, if there are no other questions, I thank you all for attending.
Nice of them to add concat, but I wish they had added it as an aggregate.
I'm sorry?
I wish they had added it as an aggregate
For which one?
for concat. I want to say concat, calculated field from a table. So that I have 200 rows in my table. I want to concatenate all those strings together.
Wow.
Give me I want to, if I have a manager table,
Right.
I want to be able to write a recursive CTE and then give me the chain of everybody I'm reporting from. That's a string.
Right. Wow. That could easily go into overflow, though.
Oh, absolutely.
Right.
Absolutely. Yeah, I mean,
But you're right. It would make it easier.
It's a powerful tool that could be very easily misused.
Right. A lot of these functions, they can be misused, and they could be written in a very cryptic way and inefficient, very difficult to debug.
But
Yes.
for example, I was writing a critical path analysis for